Okay, matrices and data. So what we're going to do today is look at the introduction for matrices, and then tomorrow we'll, I'm not sure yet what we're going to do besides eating pie and cookies, so, all right, who knows. Okay. All right, this table shows the top scorers for girls in barrel racing at the 2004 National High School Rodeo Finals. Do we have any equestrian people in here?
Oh, yeah.
Good. All right. Caitlin, are you on the equestrian team that we have here? Awesome. Do you do the barrel racing?
I wish.
You wish? Okay. All right. So what we do with matrices is we take a set of data, and to simplify the way it looks, we can put it in what's called a matrix. And so here they have these National High School Rodeo Finals. They show the barrel racing scores where a couple of young ladies were racing. And with their information in the table, they've actually taken it and put it into what's called a matrix. And with a matrix, we have, we usually call it something, so like matrix A, matrix B. And we have rows and columns. So if we go down, we have rows, and we go across, we have columns. And so we can set up our table just like we do with the row in the rows and columns, and so it looks exactly the same. And when we describe a matrix, we describe it by its dimensions, which would be the number of rows by the number of columns. So this would be a 2 by 3 matrix. So, all right, so I go down 2 and over 3. All right, it's 2 by 3 matrix. Each value in a matrix is called an entry, and each entry has what's called an address. So according to the row number and the column number, it has an address. So like that one on the bottom left is row 2, column 1. So they would put lowercase a and 21 there, the 2 representing the row, 1 representing the column. And over here where they've got 17.668, that would be A sub, because you're going to put it as a subscript, 23. All right, so the address there would be A and then 23 for the 17.668. So today we're going to look at just setting up a matrix and then doing a little bit of addition, subtraction, and multiplying by a scalar or a constant. Okay, doing some distributing. So here we have the prices for different sandwiches. All right, roast beef, turkey, tuna, and the prices for 6-inch and 9-inch. Whenever we display a matrix, we use brackets to do it. So you've got the little hangovers there. So you're not using parentheses, we're using brackets, so they're squared off. So when I display the data, these numbers in a matrix, I'm going to put them just like they are. Now, when you do a matrix, there are no commas. Okay? There's nothing to separate the numbers except for space. So you're developing, so basically you're taking this table and with the numbers and you're getting rid of all the lines. Okay? That's basically what it is. So it'll look just like this. All right, all I've done is get rid of the lines. So the dimensions of a matrix is determined by the number of rows and the number of columns. So you count down for the rows, count across for how many columns there are. So this would be a 3 by 2 matrix. There's 3 rows and 2 columns. The entry at P32, so that means I want to go to the third column, or the third row, excuse me, second column, which would be here at 5.25. So what does it represent? It represents the price of a 9-inch tuna sandwich. So how many of you, when you go to Subway, you get a tuna sandwich? Anybody? For real, you do?
No, for real though.
Okay.
That's what I got the last time I went to Subway.
Yeah. What condiments? What side stuff do you put on it?
Like lettuce, pickles, and mustard.
Mustard. You get jalapeno peppers on it too? No.
Banana peppers.
Banana peppers.
Grilled, pepper jack cheese.
Yeah. Awesome.
That's pretty
Okay.
good. Okay.
That sounds good. Okay. The address of the entry 5.95. Right. So 5.95 is here. So that would be which row? Okay, the first row and the second column. So I would say that that is then P, and it's a subscript, so you would say P sub 1, 2, or P sub 12 for that one. Okay, now we're going to look at adding and subtracting matrices. To be able to add and subtract matrices, we have to be able to add and subtract the same entries in both matrices. So the first thing that is important about adding and subtracting is the matrices must have the same dimensions. Okay? So if you're going to add two matrices together, they must be the same. Like here we have a 2 by 2 and a 2 by 2, so I can add them. These two are both 3 by 1s, so I can add them because I'm just going to add corresponding entries. So we would go 1 plus 2, 2 plus 1, 6 plus 7, 7 plus 6. Okay. Or just add these, 5 and 2, 6 and 8, 7 and 1. So they have to be able to add and subtract. You've got to have the same size matrices. These don't work, okay, because the matrices are different sizes. All right, so here we have 4 matrices, and we're going to add and subtract some of them, if possible. All right, so let's go through the dimensions first of all and write those down to help us out. Okay. Our first matrix, W, is a 2 by 2. X is a 2 by 3. Y is a 2 by 2. And Z is a 2 by 3. So I can only combine W and Y because they're the same size, and X and Z because they're the same size. So if I ever try to add or subtract any of the other ones, can't do it because they're different dimensions. So letter A, they want us to add W and Y. So that means we're just going to add the corresponding entries in each matrix. So we'll add 3 plus 1, negative 2 plus 4, 1 plus negative 2, and 0 plus 3. When you do this, you don't have to do this step. Okay, that's up to you if you want to write it out. You guys are intelligent enough that you don't necessarily need to write that step. If you want to, you're more than welcome to, but you don't have to. So if we add 3 and 1, we get 4. Negative 2 and 4, we get 2. 1 and negative 2 get negative 1. 0 and 3 get 3. So the sum of those two matrices is that matrix. So when you add or subtract two matrices together, they have to have the same dimensions to do that. And when you're done, you're going to get a matrix with those same dimensions. When we talk about multiplication, it's a little bit different. But when you're adding and subtracting, same dimensions, you get the same dimensions. X minus z. So we're subtracting. So then we're going to subtract the corresponding entries. So you can write it out if you want, but you don't have to. So let's just do that one then. So I'm going to subtract. So I do 4 minus 2. I'm going to put it out here. I'm going to write bigger. 4 minus 2 is 2. So my row 1, entry 1 will be 2. 7 minus negative 2. Okay, it means we're going to add, so we get 9. 2 minus 3, negative 1. All right, so there's our first row. So we're just doing some very basic subtraction. 5 minus 1 is 4. The middle one, row or column 2, 1 minus 0 is 1. And negative 1 minus 4 is negative 5. Letter C, they want us to add x and y. X is a 2 by 3. Y is a 2 by 2. Different dimensions. Cannot add them. Okay. Now we know that multiplication is repeated addition. So the same is true for matrices. For example, if we wanted to add E plus E together, we could do that, or we could just say 2 times matrix E, which means then all that is that we're just going to double all of the values in the matrix. So if I did 2 times that matrix, then we're just going to do 2 times each value in the matrix. It's called a scalar. We're multiplying by a scalar, which means we're just going to increase the size or decrease the size of them by a multiple. Okay, here we have a business there where they sell t-shirts and sweatshirts. And they've listed the shirt prices for us depending on the size of the shirt. They want us to use a scalar product to find the prices if a 10% discount is applied to the prices above. And I've actually just done this as a regular problem, not putting a matrix C in there. You can put a matrix C in here, okay, and use that. In this case, they're just asking us for those prices. So we can do it right in a table. So what happens if I have a 10% discount? What do we do? Okay, all right, 10% discount. How many people say we multiply by 0.1? Okay, all right. How many people think we multiply by 1.1? Okay. And then subtract it. Maybe multiply by 0.1 and subtract. Okay. Well, if I multiply by 1.1, that numbers then are going to get bigger. But a discount means you're going to pay less. Okay, nice try. All right. Now, so if we multiply by 10%, then what do we have to do? Subtract it from the original, right? Is there another easier way we could do that than multiplying by 0.1 and subtract? We could multiply by 0.9 and then we don't have to do any. Okay? So we start at 100%. If we get a 10% discount, that means we're going to pay 90% of the original price. So then what I can do is I can just do the scalar multiplication, which just says I'm going to multiply each of these by 0.9. So that should give me $6.75, $7.20, $8.10, I'm going down, and $9. All right. I'm doing fast multiplication. In other words, I'm just subtracting 10%. Okay. This would be 1350. 1750, 90% of 1750 is 1575, right? Right, Megan? Let's see, what's 10% of 1750? $1.75, right? Okay, if I subtract $1.75 from 1750, 1575, right? Okay. And then $18, and then subtract 225 would be 2025, right? Okay. All right. So multiply by 0.9, easiest way if you want to use your calculator. If you don't want to use your calculator, use your head and go from there. Not always so easy. All right, one more. So we're going to take matrices, add them and subtract them, but also do some scalar multiplication at the same time. So here we have three matrices that we're going to do a little bit of work with, adding, subtracting, and some scalar multiplication. Now, the thing you want to make sure of is that whenever you're doing this, that you do the scalar multiplication first, and then do your adding or subtracting. So we are going to do this. 3 times matrix P, so 3, -2, 1, 0, 2, -1. 3 times that matrix, and then I'm going to subtract this one here. Okay? So we always want to make sure we do the multiplication first. So we should write down the dimensions just to make sure we're thinking correctly. All right. So this one here is a 3 by 2, right? Okay, 3 rows, 2 columns. This one is a 2 by 3. Are those dimensions the same? No, so I can't do this. Okay, so this is not possible. We must have the same dimensions to be able to do that. Okay. Letter B, they want us to do 3r minus p. Okay. So we can check our dimensions. R is a 3 by 2. P is a 3 by 2. All right, that one will work. So 3 times 1, 4, So we're going to multiply. I know the dimensions are the same. So we'll multiply the first one by 3 and then do our subtraction. So we get 3, 12, negative 6, 9, 0, and 12. It's a bad 4. Then we do our subtraction. 3 minus 3 is 0. 12 minus negative 2 would be 14. Negative 6 minus 1, negative 7. 9 minus 0 is 9. 0 minus 2 is negative 2. And 12 minus negative 1 would be 13. Okay. So do the scalar multiplication first, and then do any adding and subtracting after that. Right. Some of you might try to do it all in one step, and that's fine if you can. But I would always suggest that you do the one before you do the other. Any questions about those? Not too bad.